flying due south. At 10 o'clock, point P, point Papa, bears 267 from aircraft. At 10 hours 6 minutes, same point bears 275 from aircraft. If aircraft has a ground speed of 120 knots, estimate the range of aircraft from point P. Okay, estimate the range of aircraft. Now over here, the heading of aircraft is 180. Next, this is your point P. Okay, so at 10 o'clock, relative bearing is 267. So if relative bearing is 267 and heading 180, the track to this Papa, point Papa or to this station will be equal to QDM, relative bearing plus heading. So 180 plus 267 is equal to 087. Okay, 087. Next at 10 o'clock, 10:06, relative bearing is 275. QDM in that case will be relative bearing plus heading, which is equal to 180 plus 275, that is equal to 095. Looking at this tracks, aircraft is going to be here at 10 o'clock. At 10 o'clock 6 minutes it's going to be here. So at 10 o'clock, the track to the station is this. At 10 o'clock 6 minutes, the track to the station is this. Let's join that. When it travels from this point to this point in 6 minutes, it covers a distance of how much? So it covers a distance of 180, 120 knots into 6 minutes, which is 12 nautical miles. So let's substitute the values. Eight degree equals to 12 divided by distance gone into 60. So distance gone equals to 12 into 60 divided by 8. 12 into 60 divided by 8 is 90. So this answer is 90 nautical miles. X equals to 90 miles. Okay. So this is how you do the sum. What is the range of aircraft from point P? It is 90 nautical miles. Next question number 2. You are approaching Austria on a glide slope of 3.5. What height should you be at 2 miles away from the runway? Right. So let's say this is your runway. Okay, you are approaching distance away from the runway is 2 miles. Angle is 3.5 degree. And now you have to find height. height equals to, or use 1 in 60 rule here. So angle equals to distance of track divided by distance gone into 60. So height will be equal to 3.5 into 2 divided by 60. So 3.5 divided by 30, that is, you will 3.5 divided by 30. So you will get this answer in nautical miles. Convert that into feet. To do that, multiply by 6,000. So it becomes 700 feet. So aircraft is 700 feet high. If you use tan theta formula, tan of 3.5 equals to height upon 2. So height will be equal to tan 3.5 multiplied by 2. So tan of 3.5 into 2 into 6,000. So you get 734 as answer. 734 feet using tan theta formula. So look at the options given in the question and select a suitable option, the closest option. Question 3. You are approaching Spain on runway 28, glide slope 2.6, and the range is 4 nautical miles. So similar question. This is your runway and this is the glide slope to glide slope 2.6, distance 4, you have to find height. Okay, this is the plane. So let's use 1 in 60 rule formula. Angle equals to distance of track divided by distance gone into 60. So 2.6 into 4 divided by 60. 2.6 into 4 divided by 60 is, you will get an answer in nautical miles, 0.17333. Multiply that by 6,000. So final answer will be 1040. So your aircraft is at 1040 feet when it is 4 miles away from this runway. Now let's use tan theta also once. Tan 2.6 is height upon 4. So height equals to 4 into tan 2.6. Tan 2.6 into 4 into 6,000 is 1090. 1090 feet. Okay. Next. Question 4. You are approaching Paris on a slope of 3 degree. What height should you be at a range of 2 miles? So this is your runway. Okay. There is your aircraft here. The distance is 2 miles. Glide slope is 3 degree. Now using 1 in 60 rule, 3 degree equals to distance of track, that is height of aircraft, divided by distance gone into 60. Height equals to 2 into 3 divided by 60 is equal to 0.1. Okay, to 6,000, you get 600 feet. So zero point 0.1 nautical mile or 600 feet. So your aircraft is 600 feet high. Question number 5. You are approaching Austria on a slope of 3.5 degree. What height should you be at 2 miles? What rate of descent what should be your rate of descent at a speed of 120 knots? So this is your runway. Okay. You are 2 nautical miles away. Glide slope is 3.5 degrees. You have to find height of your aircraft. Using 1 in 60 rule, angle equals to distance of track divided by distance gone into 60. So height will be equal to 3.5 into 2 divided by, so 3.5 degree equals to distance of track divided by distance gone into 60. So distance of track equals to 3.5 into 2 divided by 60. So 3.5 into 2 divided by 60 equals to, so and so answer, multiply by 6000, you get answer 700 feet. So your aircraft is 700 feet high. Okay, simple. Next, rate of descent is how much? Rate of descent is how much? Rate of descent formula is rate of descent equals to your ground speed into ground slope, correction, glide slope divided by 60. Speed is 120, slope is 3.5 divided by 60. Now this 120 is knots. Convert 120 knots into feet per minute. 1 knot equals to 101 feet per minute. So 120 will be equal to 120 into 101. Now do the calculation. 120 into 3.5 into 101 divided by 60, which is 707 feet per minute. So answer is rate of descent will be 707 feet per minute. Next, you are approaching Spain on runway 28, glide slope, height and rate of descent. So again, this is your runway here. Okay, distance is 4 miles. Height we have to find out. Glide slope is 2.6 degrees. This is your aircraft. Okay. Using 1 in 60 rule, angle equals to distance of track divided by distance gone into 60. So 2.6 into 4 divided by 60. 2.6 into 4 divided by 60 into 6000. To convert nautical miles into feet, you get answer 1040 feet. Okay. So your height, the height of aircraft is 1040. Next, rate of descent equals to ground speed into glide slope divided by 60. Speed here is 180. Slope is 2.5, 2.6 divided by 60. Convert 180 knots into 50 feet per minute. So multiply by 101. Now 180 into 2.6 into 101 divided by 60, which is equal to 788 feet per minute. Okay, 788 feet per minute. Next, very simple. Next question 5, Charlie. At what height should you be at a range of 2 miles? What rate of descent? So rate of descent will be equal to, now this question 5, Charlie, is similar to question 4. Okay, in terms of finding height of aircraft. Now rate of descent is speed into slope by 60. So 150 knots into 101 into 3 degrees by 60. So rate of descent is 150 into 101 into 3 divided by 60, 757.5 feet per minute, or approximately 760 feet. Heathrow, runway 27, slope 3 degree. You reduce speed from 150 to 120 knots. What change should you make to your rate of descent to maintain this glide slope? Okay, now speed has been reduced from, so initial speed from 150 knots to 120 knots. That means a decrease of 30 knots. A decrease of 30 knot, right? Now, whenever there is a decrease in rate of decrease, ground speed decreases either due to change in headwind, that is either due to increase in headwind component, or automatically because of pilot. Okay, so ground speed can decrease in two conditions: increase in headwind strength, or the pilot chooses to decrease his ground speed on his own. Okay, so whenever ground speed decreases, rate of descent will increase. Will increase. Okay, so in order to prevent that from happening, the pilot should control his rate of descent so as to maintain 3-degree glide path. Otherwise, he will deviate from his 3-degree glide path and come and undershoot the runway. Okay, so whenever ground speed decreases, either due to headwind change or by pilot inputs, rate of descent will increase. The solution to that is control your rate of descent or stop your rate of descent from increasing. Anticipate, be ready, take action. Control your rate of descent. Okay, so you control your rate of descent. In other words, decrease your rate of descent. If you don't do that, your rate of descent will increase and you will undershoot. Decrease the rate of descent. So by what value should you decrease your rate of descent? So change in rate of descent will be equal to change in ground speed multiplied by 5. Now over here the change is 30 knots. So 30 into 5, which is 150. 150 feet per minute. So change in rate of descent of 150 feet per minute. So what change should you make to your rate of descent? You should decrease your rate of descent by 150 feet per minute. Okay, to maintain glide slope 3 degrees. Next, question number 7. You are flying an aircraft in Italy on a slope of 2.5 degrees. Having had a hydraulic failure, you can't select any flaps. Your approach speed is 220 and have a headwind component 10 knots. What rate of descent do you need to maintain the glide slope? Now, rate of descent formula is ground speed to glide slope divided by 60. Okay. Now here true airspeed is 220 knots. Headwind is 10 knots. So ground speed will be equal to dash minus headwind 220 minus 10, which is 210. So substituting the values, 210 knots into 101 in feet per minute into 2.5 degree glide slope divided by 60. So 210 into 101 into 2.5 divided by 60 is 884 feet per minute. Okay, approximately 800 feet, 884, approximately 900 feet per minute. Next, question 8. Question 7. On the approach, you regain some hydraulic power. Subsequent to that question. Select mid flaps position This enables you to reduce your speed to a new speed of 190 knots. What change in rate of descent is required to maintain the glide slope? Okay, so let's write here. Initially, TAS was equal to 20 knots and a headwind of 10 knots. Okay, initially your TAS was 220 knots. Now your TAS is 190 knots. Right? We have to find out the change in the rate of descent required. Now, whenever a speed to a speed ground speed decreases, the rate of descent increases. Okay, so in order to prevent that from happening, you control the rate of descent, meaning what you actually do is you decrease rate of descent. Now change in rate of descent equal to change in ground speed or true airspeed in this case into 5. Now the change is equal to 220 minus 90, that is 30 knots. So 30 into 5, which is 150 feet per minute. So rate of descent change is equal to 150 feet per minute. Fine. So 150 feet per minute change in rate of descent is required to maintain glide slope. Now what is your new rate of descent? So new rate of descent will be equal to new ground speed. Okay, not true airspeed, ground speed into slope by 60. Now what is your new ground speed? TAS is 190, headwind is 10, so ground speed will be 180, 190 minus 10. So 180 into 101 into glide slope is 2.5 by 60. So 180 into 101 into 2.5 by 60. 757.5 feet per minute, approximately 760 feet per minute. So this is your next answer to the next part. Question 8. You are flying on an airway with a center line QDM 137. So track towards the station is 137, magnetic track. Your RMI reads 141, distance 90 miles. Are you left or right of the center line? What is your distance of the airway center line? Are you in trouble with ATC? Airways normally extend 5 miles either side of the center line. So QDM to the station is 137. Your RMI reads 141. So the track towards the station is 137. Your RMI reads. So RMI will indicate QDM to the station. is 141. ODR will be equal to 321. So the track towards the station is QDM 137. Okay, this is the original track to go towards the VOR station. Okay, to go towards the VOR station. Fine. Let's say from this location. Now, if your aircraft is able to fly this track towards the VOR station without drifting or getting deviated from the center line of this track, RMI will also be equal to RMI will also be equal to 137. But now here the RMI, radio magnetic indicator, which always gives a direction to fly towards the station, is 141. Okay, so this is your northerly datum. This is your 137. 141 will be here. Reciprocal of 141 is 321. So 321 will be somewhere here. That means your aircraft is actually here, somewhere here. And therefore it's getting an RMI indication of fly 141 heading in order to go to VOR. Okay, the actual track it has to follow is this track, like this, a track towards the station 137. The reciprocal of 137 is 317. Okay, so it should fly this radial 317 inbound. Okay, but it is not on radial 317, it is situated on radial 321 and it is flying inbound. So there is some deviation, there is deviation between 317 and 321. Now flying inbound, when you fly inbound towards the VOR, this becomes your left hand side, this becomes your right hand side. So when you fly inbound, your left will be on this side, right hand side will be there. Okay, so now deviation. So the first question states, are you left or right of center line? So you are actually, you should be here on this track, but you are on this track. So you are to the left of the center line. Okay. Next, question B. What is your distance of the airway center line? So we have to find this off track distance. This off track distance X. So we have this triangle like this. We have to find off track distance X. Angle. Now what is the angle here? The angle between 321 and 317 is 4 degrees. Okay. And the distance along the track is 90 nautical miles. So you are 90 nautical miles away. Okay, 90 nautical miles away. So let's use 1 in 60 rule. Using 1 in 60 rule, you get 4 degree equals to distance off track, which is X, divided by distance gone, which is 90 into 60. So X equals to 4 into 90 divided by 60. So X will be equal to 6 nautical miles. So you are 6 nautical miles deviated to the left hand side of your original track. Next, are you in trouble with ATC? Airways normally extend 5 nautical mile either side. So if you are expected to follow this airway, that is radial 317 inbound, you have to follow that center line of the airway. But in case you are not able to follow the center line and you get deviated left or right, So the maximum deviation that is possible is 5 nautical mile either side. In this case, you have deviated more than 5 nautical mile to the left hand side. Okay, that is 6 nautical mile. So you have deviated beyond the permissible limit, that is 5 miles either side of the center line. So are you in trouble with ATC? Yes, you are in trouble because you have crossed that limit. Okay, so first answer is, are you left or right? You are left. You are 6 nautical miles left, and you are in trouble because you have crossed that limit. Okay, so this is how you solve this question.